times, rainy days, and Mondays with music by Roger Nichols. And since we've had a little rain, we have enough to make room for some seasonal changes. We're here for autumn leaves. Then I was walking home one day and I'm actually piece in front of me because I wanted to talk about the red leaf that I found on the way home, walking home, and I wanted to pick it up. And I left it behind and I thought, oh, I have to go back and get that red leaf. It's such a pretty leaf. So I wrote a little piece called The Red Leaf. And we're getting really close to winter time. So this is a piece called Walking in the Air for the Snowman. I'm riding in the and gazed open mouthed, taken by surprise. Nobody that below believes their eyes. We're walking in the air, we're dancing in the midnight sky, and everyone who sees us greets us as we fly. And that was music and lyrics by Howard Blake. And next up, I've always wanted to see the Northern Lights. I have not done that yet. That's on my bucket list of things to do. I'm going to change this to the key of D. Dyer, Happy Man by Thomas Rhett. Gotta go down, and I have a lever harp, so I've got to make a lot of changes. I'm going to bring this down to flats, and the naturals. I'm changing the notes with my hand on the upper part. Here we go. This is Linus and Lucy. And now if we have time, I'm going to try a little Debussy. This is Arabesque by Debussy.
Kim, just it's about 2 minutes.
Oh, I'm already out of time. Okay, I'll just do it.
How about an intro to Debussy?
Oh, okay, here comes Debussy. Oh, sorry, I'm on beat. I gotta get my beat buds back up. Never hurts. Okay.
Thank you so much, Kim. We really appreciate it. And I'm glad that we got the enlarged version of your harp so people could see what it was you were flipping. Those harping levers or sharping levers raise the pitch of the strings by half a tone, right?
Exactly. Yes, yes. Thank you so much.
Well, thanks again. We really appreciate it. And I should welcome everybody to our November meeting. This is the November meeting of Orange County Astronomers. And we have just finished the announcement slideshow that we run before the meetings with the harp accompaniment from Kim, who has been very generous with her time. For those that may have tried to tune in at 7 o'clock, which is when we normally start it. We were having some technical difficulties. We apologize for that, and I apologize to Kim because she didn't get to play the full amount that she had actually practiced. But anyway, before I turn the meeting over to our announcement crew, I would like to remind people, by the way, I am the current president. I may not be the president after the end of the next election cycle, which actually we're having to make an important step tonight, which is tonight is the last night to get your name in as somebody who wants to run for a trustee position or an officer position for the club. So if you want to do that, please send an email to Alan Smallbone. He's in the contacts list on the website or on the back of the Serious Astronomer. It was also on the slideshow, and I won't recite it because I don't think people are going to be writing it down. But please, he tells me he has not been inundated so far, though we do have a full slate. But, you know, get your name in. It's a great way to serve the club. It's a great way to learn about the club and a great way to meet some wonderful new people. And with that, I will turn it over to our announcement crew, and I see two of them are here already. Take it away.
All right, so here we go. Oh, wait, I never shared. Let's try that again. There you go.
Okay. Okay. Welcome, new members. We hope you enjoy this amazing meeting that we put up together. And if you are interested in joining any events like OVRO or just borrowing your telescope, please contact Cecilia Caballero. Hey guys, so star parties are still on hold most of the time. We have been having some with the outreach, like we had one for Laguna Woods this week. But as it's still on hold, we do have an astronomy meeting this weekend online, and beginners class are always ongoing every first Friday of the month with Dave. And again, it's online.
All right, so
by the way, if I may say, point out, we usually try to keep the meetings listed on the calendar. And it was brought to my attention recently that the astrophysics meetings are not yet shown on the calendar. We'll try to get that updated, but they are the third Friday of the month. And if you're interested in attending, they have been in session for the last couple months. And please contact the chair. The contact information is on the website.
thank you. And Barbara mentioned about the elections already. So if you're interested in running, please note that closes tonight. So please send in your information if you would like to run, and the criteria are here if you're interested in running. Voting again will be online, or we'll have the online option. You will also be able to vote via mail. The same way as last year. So if you're interested in voting online, it was very easy last year. There will be information coming out shortly about that. But you are still able to vote via regular mail on paper if you wish to do so.
Hey guys, so thank you so much for volunteering. We've already had 2 months back on ground outreach programs. We've been super busy, sometimes 3 a week. So thank you for showing up. And it's been brought to my attention that some people are not receiving any of the emails, so they haven't gone because they have no clue what's going on. So if you have been a volunteer for this past time at OCA and you haven't heard from us, would you kindly contact outreach at OCAastronomers.org and give us your new info so that we could contact you? And also, if you just joined, like I know that I saw Joseph Camera, right? New members coming in from the Laguna Woods Astronomy Club. So thank you all for coming. And that's it.
Hello, my name is Galileo, and today is going to be the first quarter. And hopefully you guys are happy and have a safe night. Okay.
And also, guys, before we close it out, all veterans out there, thank you for your service, and I hope you enjoyed our wonderful free meals all across, your city.
All right. So the Lunar Scope program is still going on, but in addition to that, some of the scopes are being sold. You can see those here. If you are interested in purchasing any of these scopes, please contact scopes@ssccorp.com, and the next pickup date will be December 11th. If you're interested in having any articles or images shared with the club through the Serious Astronomer newsletter, please send in your information to Dave Fisher for those items to be considered. As well, if you would no longer like to receive your mailed copy and just want to be able to receive it in electronic form, please contact Charlie if you'd like to do that. Again, everyone will still be getting the paper version unless you request the club to stop sending you the paper version, and the electronic version is always available online. Same rules that Ann said regarding COVID, and it's still that the club cannot maintain a sanitized environment and is not responsible for sanitizing the site. So please visit at your own risk if you wish to do so. But if you do have a pad out there, make sure to do your weed clearing, since fires don't stop because of COVID. And then that will be it. So the next general meeting is December 10th. And next will be Chris Butler with the What's Up presentation.
Are we all set for me to go? Let's give this a try. See if we can remember how to do this. We've got an awful lot to cover. All right, do you see on my screen there? All right, fantastic. Let's get into it. Only got 15 minutes and we got a lot of sky to cover. First of all, the next thing that we've got going on is sunrise and sunset. I want to mention the sunset at 4:50 p.m. tonight. That might have seemed very early. Of course, we've had the time change, but we've also had the seasons changing. So we really are having longer nights and shorter days. Well, that's good for us. We're astronomers. As far as the moon, we already had a little bit of an update here. We started out the month with a new moon. We've come around to the first quarter moon, and at the 19th, it's the night of the 18th to the 19th, we're going to have our full moon. You might have noticed that it's color-coded here orange. There's a reason for that. We're going to be having an eclipse of the moon. It's going to pass into Earth's shadow. And I'll have a little bit of information about that. For those of you who hate the moon, don't worry, it will go away, or at least it'll be in the early morning hours. We've got November 27th for last quarter, and so the very last days of this month, you'll have good dark skies. Mentioned the eclipse. Again, it's labeled on November 19. The deepest part of the eclipse will be at 1:03 a.m. Pacific time, when the moon is deepest in the shadow of the Earth. We're going to be able to see the whole thing. We're very well placed for this event. It's going to start at 10:02 when the moon just starts to encounter the outer shadow of the Earth, the penumbra, and that will not affect the moon's appearance very much until we get in closer to 11 o'clock. At 11:19, the moon will pass into the umbra, the deeper shadow of the Earth, and then it will begin having that darker red color that it gets during an eclipse. Again, maximum is 1:03 a.m. and the moon will fully exit the deepest part of the shadow at 2:47. This is not quite a total lunar eclipse because the moon is not entirely within the darkest shadow, but instead will be like 90% covered. Just the southern part of the moon will be a little bit brighter. So if you want to see this, great time to see it. If you want to watch it on TV, I don't know why you'd want to do that, but if you do, and you're going to stay inside, the Griffith Observatory is doing a live stream of the whole event. So it's very convenient. So bear that in mind. As far as the planets, it's already been mentioned that some of them are not good to look at right now. Those two are Mercury and Mars. They're in the morning sky. They're very low, fully obscured by things like dust and haze and the rising of the sun. Not a good time to look at those two. Venus has been mentioned as a good thing. I want to point out you need to catch it pretty quick. It has been hanging over there in the west at sunset for a long time, but it's going to start to drop down now pretty quickly. Over the next month, it's going to dive out of sight. So catch it now and catch it over the next 3 or 4 weeks. Again, I'll have a little bit more information on that in just a moment. Jupiter and Saturn, both bright in the evening skies, well placed, Jupiter especially, but Saturn, if you catch them, especially Saturn, in the earlier part of the evening after it gets dark. But Jupiter up and bright for a little bit longer, both pretty good targets. Uranus, I want to make a case for Uranus. Uranus actually is just about at its best. Its highest or transits at just after 11 o'clock tonight, and it's in the constellation of Aries. Neptune is also visible for viewing. It's in Aquarius, which is over where the moon is right now, and it'll be up for most of the night as well. Pluto is always a challenge, and right now it's in Sagittarius. It's not too far away from the direction of the sun, so not a terribly good time to look at it because the sunset glow interferes with Pluto. And with Pluto, you can't have really any interference. So no for Pluto just for this month. Looking over at 5 p.m., looking out in the west, there's Venus hanging there. You'll notice I've turned on its orbit so that you can see its path in the sky. It's been chasing us along that path, driving up behind us on the inside track for a couple of months. It hasn't looked like it's moved very much, but as you'll see, looking at it, it's just turned the corner. It's about to go zooming past us pretty quickly here on the inside track. Saturn, much fainter, but definitely visible, and Jupiter, brighter and definitely visible. So between Venus and Jupiter, you can find Saturn. And of course, there's the moon where it is tonight. This is a montage, a series of telescopic photographs of Venus that shows what's happening. So Venus, you can see I've labeled now about where it would be in this cycle. It's come from behind the sun being small, then it's half lit. Now it's 41% lit. As it swings between us and the sun, it will get bigger in your telescope, but it will also be increasingly a crescent, okay? This is a beautiful photograph of Saturn taken by Damien Peach, showing about the tilt of Saturn. This is taken this year. This is how it will appear. Again, catch it in the relatively early evening. As far as Jupiter, here's an outrageous picture of Jupiter, believe it or not, shot from the ground. This is not a Voyager picture. It's astounding. Detail even on Jupiter's moon Europa in this shot. Your view in your telescope may not be quite this good, maybe almost. Anyway, Jupiter, big star of the sky right now. You want to watch Jupiter. And a shout out for Uranus. I told you it's beautifully placed. It won't be this large in a telescope. It's a little green fuzzy dot. Here it's enlarged. Actually, a very nice photograph of it, shot by an amateur astronomer. Beautifully placed at this time. As far as the wider sky here, I've mentioned some solar system objects. This is the 9 p.m. sky. This is not the sky as it first gets dark. This is a couple hours after that. So the sky's rotated a little bit. That's why you can't see Venus over there in the west. It's already set in this diagram. Here's some solar system objects to give you an idea. The moon, where it is tonight, of course it will move. Jupiter, you can see, and Saturn down there in the southwest. And you have Neptune. Notice Neptune, it's in Aquarius, okay? So it's just the other side of Jupiter from Saturn. Uranus a little bit farther over in the sky to the east and a bit higher in the sky as well. There are lots of stars you could look at now. I'm not going to cover all of them. I'll just name a few of them. In the west and northwest, you have the stars you've been looking at all summer, the summer triangle of Vega, Deneb, and Altair in summer constellations. In the south, down below the moon, you can see one star kind of off by itself. That's Fomalhaut, the mouth of the southern fish, which is kind of all out by itself. Polaris, right where you left it, in the north. It doesn't move around. Of course, it's right over the Earth's North Pole, so all the stars seem to swing around it. But things do change in the sky, and over in the east, you've got stars like Capella, leading the bright winter stars into the sky. The seven sisters, the Pleiades, you may notice those rising in the east, followed by Orion the Hunter, marked by Betelgeuse and Rigel. I'm not going to be focusing on these constellations this month, but a quick shout out just to remind you that they are visible this time of year. The zodiac constellations of Capricornus, where Jupiter and Saturn are, Aquarius, where the moon is tonight and where Neptune is, Pisces, not much going on in Pisces this time, but Aries is where Uranus is. The constellation Pegasus, the wingless, legless, upside-down flying horse, is just about straight overhead, marked by a big square of stars marking the horse's body. I'm not going to cover that this month, but it is just about straight up, so be aware it's there. And to the south, we have Cetus the Sea Monster. You may notice some of the bright stars in that. And I'll call out Sculptor here. Sculptor is not a bright constellation, but it's home to a lot of galaxies. If you go hunting for galaxies, you're probably going to want to visit the deep south. Where am I going to take you? I want to take you this time between the summer stars of like Cygnus, Lyra, and Aquila, and the winter stars of Auriga, Taurus, and Orion. Between these two, there are bright constellations that you can definitely see. I call them the Rainbow Bridge for Norse mythology. The bridge the Vikings would take to Valhalla. These constellations in through here are some of my absolute favorites, and now is the right time of year to look at them. Zooming in to look at this part of the sky, we've centered on a pattern that looks like a W, very noticeable, small constellation, fairly bright stars. And on each side of this diagram, there are the summer stars on the right of your screen and the winter stars on the left. So how do we bridge that gap? Well, we're not going to change the view. I'm just going to highlight different constellations in what I call the Rainbow Bridge. Cygnus the Swan is a summer constellation. There are a whole bunch of different things to see in it. It's still high in the sky because it's so far north, so you'll probably want to have a look at that. A last hurrah for summer. In the inset image, you see a beautiful picture of one of its many signature objects, the North American Nebula Ngc 7000. Now we're getting out properly onto that rainbow bridge is the constellation of Lacerta. And you'll notice Lacerta the lizard doesn't have an inset picture because it doesn't have much in it, but it's there. And so now you've heard about it. It's right next to Cygnus if you want to take a look. Just north of the lizard is Cepheus the King. Cepheus the King looks like a house, the way a child would draw it, with a very tall, pointy top. Pretty easy star pattern to find. If anybody wants to see a star that they know has a planet going around it, this is a good chance, because the star at the top of that point, Eri or Gamma Cephei, is one of the stars we know has a planet. So you could look at that. Now, you can't see the planet, of course, with a telescope, but it's kind of fun to look and know that. There are all kinds of different objects here. There's in green, there's NGC 7023, planetary nebula. We call it a gas shell blown off by a dying star. There's a beautiful galaxy a lot of people miss, NGC 6946, the inset photograph in the lower right for that one, and a big diffuse nebula, IC 1396. Not much of a treat to the eye. It's a bit subtle, it's fairly dim, but a gorgeous target for photographers and astro imagers. Cassiopeia, I've already mentioned, one of my absolute favorites. It's one of the easiest constellations to find, known for its star clusters marked in yellow. Photographs of two of them are included, M52 in your lower right, with some nebulosity out there floating in the area. The whole constellation is lousy with nebulae. You can find lots of them. M103 is in the other picture there. One quick shout out for the beautiful double star Eta Cassiopeiae, which is not only a nice double in your telescope, it's one of the sun's nearest neighbors at only 18 light years away. Just below the W is the famous constellation of Andromeda, and it's right adjacent and connected to the square of Pegasus. Andromeda is famous for those big giant galaxies, especially the great Andromeda galaxy M31, picture in the upper right. This is something you can, it's the neighboring galaxy. It's right next door. It's a huge, big spiral galaxy. So you can even see it with the unaided eye easily if you're out in the dark sky. Binoculars, small telescopes from the city, this is a good target. Shout out to its neighbor, M33, also right next door to us here in the universe. However, it's in the neighboring constellation of Triangulum, so I'm just cheating slightly. Other objects, the planetary nebula NGC 7662 and the star cluster NGC 752. Camelopardalis doesn't get much of a shout out. Usually, this is the giraffe, and the giraffe constellation is known for having lots of galaxies. Let me call your attention to this one in particular. IC 342 is also one of our nearest neighbors in the universe. It's in the local group of galaxies, but because it's partly back behind the Milky Way, the band of the Milky Way, there are more stars, gas, and dust in the way. So it's a bit dimmer than it otherwise would be. But for astrophotographers, well, you can see the beautiful inset photograph. It's an amazing target. Lastly, Perseus is going to get us all the way over to winter. Perseus, the hero there, marked by the bright star Merfac, and its variable star neighbor Algol, has a bunch of star clusters in it, and almost always I show you the picture of the double cluster. The double cluster is incredible, 2 star clusters in the same field of view of your telescope. It's gorgeous, it's beautiful, and I do it every time I mention Perseus, so this time I'll be different and show you a picture of the fainter but very beautiful California Nebula NGC 1499. So that's a lot on that rainbow bridge for you to cover, as you can see. It's all packed into a small part of the sky and easy to find. One last note before I leave you. The sky at 5 a.m., should you stay up like for the lunar eclipse, and you look at the sky at that time, it will have rotated around a lot. The winter stars will already have passed overhead, Orion, all the rest of those. They will be over in the east by that hour, and you're even going to have springtime constellations rising up before the sun rises, like Ursa Major, the Great Bear, Leo the Lion, Bootes, Virgo, all of these will be there as well. So that's a pretty packed evening for you all, in addition to a lunar eclipse. With that, I will leave you with a picture here from my buddy Adam, who was crazy enough to go to Alaska in November, hoping he could see the Aurora Borealis. And guess what? He saw it. So good for him, and good for all of you. Get out and do some stargazing. Thank you very much.
Thank you, Chris. That was great. We really enjoyed it. Very happy to have you with us all the time. Hi, my name is Reza, and I'm the Vice President of the club. I, too, would like to welcome you to the November 12th, 2021 General Meeting of the Orange County Astronomers. At this meeting, without further ado, let me just jump into the main talk. Our speaker at this meeting is a world-renowned photographer of the night sky, especially known for his images of auroras from his backyard and everywhere else that they can be seen. He's a regular contributor to the Sky News, Canada's stargazing magazine, and also to Sky and Telescope magazine. His photos and videos have appeared on spaceweather.com, Astronomy Picture of the Day, Universe Today, Forbes, National Geographic, Time, NBC News, and CBS News. The main belt asteroid number 78434 is named after him. In 2018, Canada Post issued a stamp featuring one of his images. His co-authored book, The Backyard Astronomer's Guide, is just out in a greatly revised and thoroughly updated 4th edition. Please join me in welcoming Mr. Alan Dyer. Mr. Dyer.
Thank you, Reza. Thank you very much and for the invitation to speak tonight to the OCA. It's a club I've known about for many, many years, since my days working at Astronomy magazine. Oh, a long time ago. I don't want to think about it. When one of my jobs was to compile, I think we had an annual list of all the astronomy clubs in the US or something like that, and the star parties that they organized. And so I got familiar with all the names of all the clubs and whoever the main contact person was at the club. And so I certainly remember the Orange County Astronomers from then. And it's a well-known club with lots of great members. And just looking at some of the photographs I'm seeing tonight, lots of people taking great pictures and the like. So my talk tonight is about something you don't see very often from Southern California, but I'm guessing you kind of like to see because, well, here it is here from my backyard. I'm going to talk about this one as well. This is a special aurora of sorts called Steve. However, tonight I'm live now, and I'll come back live at the end for Q&A. But I live in outback rural Alberta, and so my internet connection, I don't trust it to be good enough to support a full talk for an important audience like this. And so I pre-recorded the talk and pre-recorded the screen. It sort of looks like a Zoom presentation, but it's a screen capture. And Alan has that talk. And so we tried that before, and it seems to be working fine. So without further ado, Alan, if you've got it queued up, we can just get right into my talk. And it kind of explains the introduction in the talk itself. And then I'll come back at the end, we'll take Q&A. Well, good evening, everyone. Welcome to my talk. Thank you very much for attending this evening and for the invitation to speak this evening about a topic that I'm fond of and have the opportunity to see from my backyard as I'm showing you here, the Northern Lights. It's on the bucket list. Seeing the Northern Lights, or the Aurora Borealis in this case. There is an Aurora Australis, but mostly it's the Northern Lights that people want to and are able to chase, to see, to add it to their bucket list experiences of the night sky. As I said, I'm fortunate enough to live in Western Canada here, Southern Alberta, where we can see the Northern Lights from time to time right from my backyard. I don't have to chase anywhere. This was, as I record this, a couple of nights ago on October 11th, when we had an all-sky display. It was seen across Western Canada and well down into the northern United States as well. It was one of these great displays, and there was warnings out and that people might be able to see something that night. And indeed, the sky did perform very, very well. And we got a classic display of Northern Lights and also some other odd phenomena. I'll talk a little bit about some of these as we go along as well. This was a case of this anomalous red arc across the southern part of the sky here, along with these green blobs. So I'll talk about some of the other oddities of the Northern Lights as well as we go along. We'll finish off talking about Steve, the infamous Steve. Tonight, the topics are where to go to see the Northern Lights, when to go to see the Northern Lights, what causes them. There's some misconceptions. How to know when to look, where you can get notices and warnings. What to see, the colors. What can you see of the colors of the Northern Lights? What everybody wants to see. They can be elusive. And how to capture the Northern Lights. Very easily done with modern cameras today. And we'll finish off talking about the infamous Steve Aurora, kind of discovered around where I am here in Southern Alberta. I'll tell their story in a moment. Well, first of all, where to go to see the Northern Lights? Obviously, you want to go north to see the Northern Lights. Here in Western Canada, we can see them quite often, usually, as this picture shows, low in the northern sky. This was on a June or midsummer night from a lake not far from where I live, where there's the Northern Lights, and also just close to the horizon, some noctilucent clouds as well. We're fortunate we can see them kind of year-round here from where I live. But if you want to increase your chances of seeing the Northern Lights, you want to go to where they're visible most often and are most spectacular when they do appear. Now, that's where I live, in Southern Alberta in Western Canada here, about 100 kilometers east of Calgary. And so I can see them off to the north because the main zone where the aurora is seen is this auroral oval, this oval of frequency of where the Northern Lights most often appear. They're not most often seen way in the very high Arctic or at the North Pole. They're centered on this oval around the North Geomagnetic Pole in the high Arctic islands of Canada. So it's around this auroral oval that are our prime aurora tourist destinations. Norway, I'll show you some pictures from Norway. Churchill, Manitoba, where I was going every year until the last couple of years. And then Yellowknife in the Northwest Territories in northern Canada. All spots right along and underneath the auroral oval, where you increase your chances of seeing the northern lights on a week or 2 week trip or whatever, with the goal in mind of checking that bucket list item off. Or Alaska. I've not been to Alaska yet, nor Iceland. Friends have gone there and rave about it. A great, incredible scenery at both locations as well, and also prime destinations to see the northern lights. So those are destinations on my bucket list to get to see, just to experience the aurora from a different location. So you might want to go up to Alaska, Anchorage and Fairbanks, prime destinations to head to see the northern lights and stay within the United States. Here's the auroral oval from Norway. The aurora forms along that band as really kind of a circular band across the sky is often how it starts off, and here it is. From Norway, we're looking north. You can see the Big Dipper. When I go to Norway, or was going to Norway, I was a lecturer on the Hurtigruten ferry ships up and down that ply the Norwegian coast from Bergen up to Kirkenes, and you're above the Arctic Circle and in the auroral zone for about half that trip. And so lots of tourists go on those ships specifically to see the northern lights, in addition to the fantastic coastal scenery along the Norwegian coast as well. So there's the oval stretching across the northern sky. Now here it is seen over North America from space, looking down from space from one of the NASA or the NOAA satellites in this case. You can see that auroral band, the actual aurora, stretching across northern Canada here. And again, at the bottom left is where I live, near Calgary, and there's Churchill. Did a little dot of light on the shore of Hudson's Bay, and Yellowknife, a little bigger dot of light on the shore of Great Slave Lake in Canada's Northwest Territories. 2 locations in Canada I go to chase the northern lights, to see them overhead, or in this case, this night they would have seen them to the south. Here's the auroral oval from Churchill, Manitoba. In the middle of winter when we go there at the Churchill Northern Studies Center. I'll show you some other pictures as we go along, but there it is. There's that oval stretching all the way across the sky from east to west and going across the northern sky, or typically coming up right overhead and even into the south, as you can see over to the left picture there, a bit of a faint band of aurora through Orion. And here is the auroral oval 2 nights ago as I record this. Again, look, as the display started, it eventually did fill the whole sky from southern Alberta here. But it started off as this arc of light stretching across sort of 180 degrees of sky from east to west as you're looking north to see the main auroral oval. People much further north up in Yellowknife would have seen it right overhead at that time. So where do you have to go? Well, it's not enough to say just go as far north as possible, because you can go maybe too far north. Or you can wait for the aurora to come to you. And this is a diagram produced by Chris Ratzlaff, a colleague here in Calgary, who is one of the administrators for the Alberta Aurora Chasers Facebook group, and I'll talk more about them towards the end. But this sort of shows you where you can see the aurora on the horizon at various KP planetary index levels. Sort of these are the main indicators for whether there's going to be a bright aurora or not. The KP index goes from 0, nothing, to 1 or 2, where it typically is, up to 9. But typically in the 3 to 5 or 6 range is kind of where you want it to be to begin to have some chance of seeing the northern lights. But at KP, let's see, KP1, there we are, KP1, you're seeing the aurora just on the horizon from central Manitoba, northern Alberta, way up in northern BC. KP1, kind of the lowest level, just as a glow along the horizon. KP2, the aurora is coming down a little bit farther south, going up a little bit higher in the sky, and you're seeing a bit more along the horizon. They're seeing it from Edmonton and Saskatoon now. At KP3, people in Winnipeg, and where I live in southern Alberta, we're seeing aurora as well, but again, just as a glow along the horizon. Nothing terribly exciting, perhaps. But at KP4, things are getting more interesting, more exciting. People are now beginning to see the aurora from just into the northern United States, but from that central area, North Dakota, Minnesota, the Upper Peninsula of Michigan. Those are the prime aurora viewing areas in the lower 48 of the U.S. KP4, they're beginning to see it, but again, maybe just a glow along the horizon. At KP5 now, as it was a couple of nights ago, and it went up to KP6, now people are starting to get kind of excited at the prospects. If the warnings come out that that kind of KP level is imminent in the next few hours, perhaps. Now we're beginning to see the aurora further south into central Minnesota, Montana, and the like, and further down into Wisconsin. KP6, now we're probably in for a pretty good show, at least in the northern part of the U.S., as we had a few nights ago here. And we're seeing it very prominent in our skies in Western Canada. But it's got to get up pretty high, even to see it from Washington or Oregon, even though their latitude is not terribly different from, say, Minnesota or northern Wisconsin. They're further away from the Earth's north magnetic pole, and so it takes a higher KP to bring the aurora down over the Pacific Northwest in those parts of the world, even though their geographic latitude is not terribly different from places in North Dakota and Minnesota. Those are the prime destinations to visit, to plan a trip, if you want to stay in the lower 48 of the U.S. to see the northern lights. But it's got to get up to KP4 or 5 or 6. Now, you do, however, want to see the northern lights as more than just a glow along the horizon. That might be neat, but you really want to see it overhead, as I'll show you in a few pictures now in a moment here. But now KP1, we're seeing it overhead way up in northern Alberta, KP3 in northern Alberta, central Saskatchewan and Manitoba. KP5, we're seeing the aurora overhead in Winnipeg, Regina, and into Calgary. KP6, southern Alberta, we're seeing it now overhead from where I live, as we did a couple of nights ago. But just into North Dakota and northern Minnesota and the Upper Peninsula of Michigan at KP6. It's got to get up to a very high KP to begin to show a really dramatic display of northern lights much further south than that in the United States. So KP is one of the main indicators that we look for. You'll see that on spaceweather.com and various apps I'll tell you about. The other one is the BZ or BZ index of magnetic fields coming from the sun. And that should be south or negative, because you can get very high KP, but if the BZ is north, then the magnetic fields of the interplanetary fields coming from the sun don't connect with the Earth's magnetic field, which is pointed north. You need a south-pointing field coming from the sun to connect better with the Earth's magnetic field. So that BZ should be south and as far south as possible. And there are usually charts as well on some of the apps I'll show you where it shows the current BZ, what direction it is, and we want it to be south or looks like it's going to head south in the next few minutes, and it can change from minute to minute, certainly hour to hour during a typical magnetic storm as well. So we suddenly see more aurora in an outburst, in a storm as well. So the BZ index is very important as an indicator as well. Sometimes the warnings go out that we're going to get a high KP that night and it fizzles. We don't get anything because that BZ never went south far enough to really connect with the Earth's magnetic field. But this is what you want to see, however, and this is what you want to chase for. This is what you want to go north for, to get underneath your auroral oval, so you are underneath the aurora. It is overhead. This is from the Norwegian coast, where it's just dancing over the whole sky. This is from Yellowknife, 62 degrees north latitude, prime location underneath the auroral oval, where it's just dancing over the whole sky, and your jaw just drops. You cannot take it all in. It's hard to imagine the sky is capable of doing this. It's just absolutely marvelous. This is a real-time video taken during display like that, but now looking more at the horizon, but it's coming up right overhead. But this is real-time video. This is not time-lapse. This is not sped up. Cameras are capable of doing this, showing you the actual motion during an active display. And when it gets bright, when that KP picks up and the activity level picks up, it really starts to dance. And you see that fine rippling motion, and you see with your eyes these colors, the greens from the oxygen, the pink fringes along the bottom from nitrogen as well. This is what you pay your money to see. This is what you want to chase to see, to get underneath your roll oval, to increase your chances of a good display over all or part of the sky as well. So that was from Yellowknife a couple of years ago. This was a fabulous night up in Churchill. Same thing. This is a fisheye lens looking up over the whole sky, where just for a few minutes, what was a good display turned spectacular. And just the sky burst open, rippling like that, and these vivid pinks across the sky from nitrogen glowing at the bottom of the auroral curtains. Fabulous display. You definitely chalked it off your bucket list. You see something like that. It's up there with a total eclipse of the sun in terms of wanting to see a 10 on a scale of 10. Here is the aurora to the south now from Churchill, where it's not just overhead or to the north, it's to the south. This is the aurora that they would be seeing in their north from places farther south, up in Winnipeg perhaps. This is to the south here. And now there is a story that goes out on the news from time to time that you better see the aurora now because it's going away from us. That the Earth's magnetic pole is shifting and moving to the north and taking the aurora away with it and moving it away from being over North America and putting it more over Russia or whatever, that we're not going to see it. Well, don't worry. The Earth's magnetic pole that your compass points to is moving rapidly to the north, as the chart shows here. But that's not where the aurora particles are going to. They're not going to the Earth's magnetic pole. They're going to the Earth's geomagnetic pole. It's different, and it hasn't moved much in decades. It's up in the high Arctic islands of Canada, and that's where the aurora particles are all trying to funnel down into and intercepting the Earth's atmosphere before they can get there, of course, because the Earth gets in the way, and they form that ring of light around the north geomagnetic pole. It hasn't moved much in decades. It isn't moving much. For example, where we go in Churchill and attend to Aurora tourists at the Northern Study Centers built on the grounds of the old Churchill rocket range, where they used to launch rockets up in the Aurora, built in the 50s, 60s, and in use into the 80s, because it was underneath the Aurora. It still is. They're not launching rockets there anymore, but it's still prime location underneath your auroral oval. It hasn't changed much in decades. So don't worry about that. Now, when to go, however, you do want to plan exactly when to go. From where I live, as I said, we can see an all-sky aurora perhaps even in midsummer. This was a few years ago on literally summer solstice night, I think it was, where the sky is bright from where I live at 51 degrees north. You can see perpetual twilight lighting the sky, but the sky is still dark enough that a bright display of aurora shows up, and this was a great night on another one of these KP 6 or 7 nights where we got fair warning that a good display was imminent. This was in July 2020, one of those magical nights when we had the comet Neowise around, and an aurora across the sky as well. Fabulous. So from our latitudes here in southern Western Canada, 49 degrees is our border here, 50 degrees, 51 where I live, and up to 54 or so, we can see northern lights all year round, even in midsummer. But you do not want to go up to those locations underneath your auroral oval in Alaska or Yellowknife or Iceland or whatever in midsummer. The weather might be very nice and tempting, but you're not going to see the northern lights because the sky doesn't get dark enough from those kinds of latitudes. You don't have to be above the Arctic Circle. Even at Yellowknife at 62 degrees north, it's not dark enough from essentially April to early August or so. So from Churchill, for example, it's only at 58 degrees north, prime location underneath the oval, because it's the north geomagnetic pole is due north of Churchill. And so the auroral oval comes farther south over North America at that longitude, sort of Manitoba and up into Churchill. And so we're only at 58 degrees north, but even so, the sky is not dark enough in summer. It's kind of late August to late April is aurora season in Churchill. And we take people up there at the Northern Studies Center to see the Northern Lights in midwinter. Yes, it's cold in February and March, but that's when the chances of the clearest skies are in midwinter. Right now, at this time of the year, October and November, prime tourist destination to go to Churchill to see the polar bears, which are gathering to migrate out onto the Hudson's Bay ice as the ice freezes up. But it's very cloudy a lot of the times. Even though the aurora might be happening, people aren't seeing it. It's midwinter, true of Churchill, true of a lot of locations in the Arctic. You kind of want to go there in midwinter because that's when the skies are clearest, even though it's minus 30 or something Celsius at Churchill at that time. But nevertheless, people have a great time there, and the displays are fabulous up in Churchill, Manitoba. But you're not going north to see the aurora because the aurora needs cold weather. That's a misconception, that somehow it's the cold weather that generates or is responsible for or is necessary for the aurora to happen. That's not true. The aurora is happening hundreds of kilometers up there, nothing to do with the weather down here on Earth, doesn't affect the weather down here, and the weather down here does not cause the aurora or suppress the aurora in any way. You're just going north in the midwinter to get the clear skies. The long nights as well are an advantage, but it's the clear skies when it's coldest is often when it's clearest from any of those sorts of locations. And here is a fabulous night in March 2016 where the aurora just went crazy in this incredible arc across the sky with these beautiful colors. So that's when we take people up to Churchill. Yellowknife, their prime tourist season is typically January, February, March as well. By April, it's getting too late and too light as well. But September to March is a good season, and I like to go up there in September. Wasn't able to this year or last year, hoping to next year perhaps, but certainly prior to that, I was going up each year. And there's a window of time in early September when it's dark enough and getting dark soon enough and dark enough to see the northern lights, but it isn't getting really cold yet, and the skies aren't clouding up. Later on into October and November, it's getting cloudy a lot. But in early September, the weather is usually pretty nice. Still coolish, but not like it'll be in February or March. So that's a prime time to go up to Yellowknife. This was a fabulous display right from downtown Yellowknife, or looking towards downtown Yellowknife from an area called Old Town at Pilot's Monument. And so the aurora is bright enough to see and photograph even from downtown Yellowknife in this case. Fabulous, fabulous night. And out of Yellowknife along what's called the Ingraham Trail, all kinds of lakes, and in early September they're not frozen yet, so you got these great views of the northern lights reflected over the water, the autumn trees and aspens turning color, the Big Dipper there. This was a fabulous night at Prelude Lake a couple of years ago. So it's a favorite location, and time to head north is that time when you're not in the dead of winter, but it's a narrow window before the clouds really start to roll in. Norway, where I go, is often October, November, and then again February, March or so. Because in Norway, at that longitude on the Earth, the auroral oval is tipped over to our side of the world because the geomagnetic pole is on our part of the world. So to head up to the oval over in the European side of the world, you've got to go right above the Arctic Circle, in this case like 69 degrees north, to get underneath that auroral oval. And yet the temperature is quite mild because of the Gulf Stream, which goes all the way up there. So even though you're going in the middle of the winter, it's not like as cold as it is here in northern North America at that similar latitude. So Norway is a great location. This was a last trip I did a couple of years ago. Panorama along the Norwegian coast. The scenery is just incredible, regardless of whether there's aurora at night or not. And what causes the aurora? This is kind of rife with some misconceptions because there's kind of general arm-waving explanations, and they're kind of inaccurate as well. Sunspots have something to do with it, but not necessarily the cause of the northern lights. And the sunspots are an indicator of the solar activity cycle. When the sun gets more active every 11-ish years or so, we're coming out of the downturn, coming out of the minimum in 2018, 2019 or so. And in the next couple of years and into 2024, 25, we'll head to another peak of solar activity level. The last peak was rather low. The couple of peaks before that, early 2000 and early 90s, were very high. We had spectacular displays during those peaks that went quite far south at that time. Some of you may remember seeing them perhaps. And so the activity level of the sun is picking up. But if you go north to the auroral oval, really the sun and the Earth's magnetic field is capable of producing great displays any time during that cycle. You just get increased chances of good activity and good displays with a solar maximum, and we're heading towards that. How high that peak will be in the next couple of years is open to debate. There's various predictions about that. And so it's activity of more sunspots, but also more flares. It's not really sunspots, but it's flares associated, explosions associated with the sun, with sunspots that blow off literally part of the sun's atmosphere into space and blow it our way. And so there's warnings out when there's been a very bright and energetic solar flare on the sun, because it causes these coronal mass ejections, these kind of bubbles of the sun's atmosphere blowing off into space, as you see here, taken from the solar, I think the SOHO satellite in this, oh no, Stereo, one of the NASA solar observing satellites, the Stereo satellite. So here it is, these bubbles of gas being blown off by energetic events on the surface of the sun. And they can head our way, but we can get good auroras even without a big flare, where we can get just holes in the corona through which there's more solar wind blowing out from the sun. And so we don't always need a major event, especially from more northern locations where you can get great displays even without some really massive flare going on. And so it is this solar wind blowing from the sun all the time that causes almost northern lights almost all the time from high latitudes. But when you get these bubbles, these coronal mass ejections coming our way, and we do get warnings now because of the NASA satellites and European satellites that indicate these and tell us, there, boom, we just got hit by one there. Sometimes they blow off from the sun and they don't intercept the Earth, as the first one or two of them does here, and they miss us. But when we get something like that hitting us, that's when the chances are higher of a great display of northern lights. Maybe. Depends on how the magnetic fields connect. So as the stuff streams from the sun, it intercepts our magnetic fields, which are like deflector shields. And the stream of solar wind, which has now got more energy because of some event on the sun, and it squeezes the field lines together in the tail of the Earth's magnetic field and imparts energy to the particles that are in the tail. And those particles rain down onto the night side of the Earth. Because obviously to see the northern lights, we have to have it at night. It has to be at night. And those particles that cause the aurora come from the night side of the Earth. They do not come from the sun, or even certainly directly from the sun. They are particles that are in the Earth's magnetic tail, which get energized by the flow of particles going past them. And they may snap the magnetic field lines together, increase that energy. It's like a particle accelerator, increases the energy of the particles that are in the fields already, and then projects them, propels them down the field lines where they intercept the Earth's atmosphere and start the air molecules and atoms in our atmosphere glowing. So here's kind of actual data from one of the NASA satellites showing you that it's a much messier process than the diagram just illustrated. Whereas the wind, it's like a windsock blowing in the wind, our tail, and you get these magnetic reconnections where the field lines are snapping together, maybe several times through a night, and you get outbursts of aurora coming and going through a night as it fades down and suddenly gets active again and dances and gets brighter and more energetic. So those magnetic reconnections can be happening all the time during a very active storm. The whole system is kind of analogous to, for those who remember, cathode ray tubes sitting in front of a picture tube to watch television or on a computer monitor when they were the big cathode ray tubes. It's kind of similar to that, where you have a source of electrons, a very hot cathode in this case, but it's that magnetic reconnection area of the Earth's magnetic field. And then you have the shifting magnetic field lines, as I just showed you, moving the electrons around and painting them onto a phosphorescent screen in the case of a CRT, but painting them onto the screen of our atmosphere and causing the molecules of oxygen and molecules of nitrogen and atoms of oxygen to glow in the characteristic green and red colors we'll show you in a moment. So the atmosphere is like a phosphorus screen being scanned by electron beams created by this heated element and modulated by magnets. So that's kind of the analogy of what's going on. But the electrons that cause the northern lights don't come from the sun directly. There is a pathway, that's where they come from. That general area downwind, down in the tail, that's where the particles come from that then get beamed back down to the Earth on the night side of the Earth. There is a channel on the day side of the Earth here where particles can get into the Earth's atmosphere directly from the sun. And right here, and they can cause dayside auroras. There are auroras in the daytime. You can't see them in a daylit sky, but from certain locations like Svalbard, 80 degrees north, in December and January, the sun doesn't rise and it doesn't get light, and it's still dark, or at least twilight, all day long, and you can see daytime auroras, but they're very weak. They're not very bright because the particles coming directly from the sun, even during a major storm, do not have enough energy to really light up the atmosphere. It takes those sort of magnetic reconnection events in the Earth's magnetic tail to impart enough energy to the particles to really slam them into the Earth's atmosphere to cause the northern lights. So the auroral outbursts are caused by the flow of solar wind interacting with and adding energy to the particles already in the magnetic tail. There's all kinds of particles out there in space, but it's the solar wind particles are not actually the direct cause of the northern lights. It's these auroral particles. They are electrons, they are protons, but they have more energy than the solar wind particles coming directly from the sun. They have that energy because they've been energized by those reconnection events in the magnetic tail and other complex activity that goes on in the tail as well. And so in some cases, the aurora that we see at night are not necessarily caused by particles that have come just from the sun. And they're caused by particles already in the magnetic tail. They may have come from the Earth originally or from the moon, but they are imparted more energy and get excited by the flow of solar wind past the magnetic tail of the Earth. So it's not really right to say, oh, the solar wind particles come flowing out from the sun, they enter the Earth's magnetic field and flow down and then cause the northern lights. Nah, it's not as simple as that. So how to know when to look? This is a view from Yellowknife, downtown Yellowknife, overlooking Frame Lake and the Prince of Wales Museum. There, how to know when to look. When should you go out, even if you're at a location where you can see the aurora, or if you want to plan a trip further north at all. This is kind of your typical auroral oval picture that's on spaceweather.com and many websites and apps and the like. And this is kind of your prime auroral oval. This is sort of standard. It's kind of always there. The red line is as far, that's where you have to be, at least as far north as that, to have any chance of seeing any kind of aurora on the horizon. It's fairly far north, but once again, from Churchill, Yellowknife, Alaska, you're maybe seeing aurora overhead, even at that kind of condition. So you'll see those kind of indicators at spaceweather.com. That's nothing very exciting unless you are right underneath the auroral oval itself, but that's now what you want to see when it lights up red like that. And the red alerts literally go out, and we're now heading up to KP 5 or 6 or 7 levels. And the aurora is moving south. So from those more northern locations, it's getting brighter, more active, but it's also moving south. Here's our red view line here. You can see now, as I showed you before, it's now heading down into the northern United States here, where they have a chance of seeing the northern lights from here, Minnesota, Wisconsin, like, but not over here, even in the Pacific Northwest, even though it's not much different in geographic latitude. So that's when it starts to get active, and if you're at one of those locations, that's when you definitely want to plan to get out of the city, get to a location where you can see the sky well and see the northern lights. So there's various Aurora apps. I like one called Aurora Forecast. It shows you that oval that's generated by the Space Weather Prediction Center that's associated with NOAA, I think it is. In fact, all these apps use the same data set from NOAA, just they display it differently. And it shows you, here's again the green kind of low-level aurora, but there it's picking up KP 4, 5, or 6 here. That's what you want to see. It's looking more energetic. Here's Space Weather Live. It's a website and app, a little more technical, gives you the current KP, the forecast KP, the BZ index as well, showing you it's south, but not too far south. And you look for that heading even farther south for an indication that it's going to get even more active that night. So Space Weather Live is another good indicator. Well, what to see in terms of the colors? People expect to see these vivid colors overhead or across in the sky, and you can see the colors, but it takes a very bright energetic display. And if you go farther north, that's your chances increase of seeing that. But it's the cameras. We're spoiled by the digital cameras that, gosh, as I'll show you at the end here, even your phones now can capture these colors very, very well, which your eyes can't, because your eyes have a limited exposure time. Even a phone camera can do an exposure of several seconds and pick up the colors much, much better than what your naked eye can. The colors are there, however. They're mostly from oxygen. The greens are from oxygen, and it's also the reds as well. But this now is more like what your eye might have seen on that kind of display. The camera with a few seconds picks up all the colors, but your eye is seeing a much weaker display. It's not even dark adapted. It's not sensitive enough. The rods in your eye are the most sensitive, but they're not sensitive to colors, only to black and white. And so it takes a very vivid display to excite the cones in your eye to see the colors. So you might see colors very subtly, perhaps, during a typical low-level display. Maybe just subtle. And it varies from person to person. I've been with groups of people where half of them are saying, yeah, I see colors, and the other half saying, I don't see any colors. So it depends a lot on the psychology and physiology of everybody's eyes as well. So people are often kind of disappointed that they're going to see those fluorescent displays with the eye. You can see the colors, but it takes a pretty bright display to do that. So the aurora colors come mostly from oxygen atoms. The green is the most prominent. Your eye is most sensitive to green, and it's typically brightest and most common. And the upper curtains can be red, deep red color. That's again oxygen, a different kind of atomic transition that's more rare. It only happens in the very, very highest part of the atmosphere where it's almost a true vacuum. You got the deep red colors. And then along the bottom is this pink fringe from nitrogen molecules as well. I'll show you a picture in a moment. But mostly it's oxygen producing the greens and reds that your eye sees, and your eye is seeing mostly the greens. In this case, there is a very faint red arc as well. That's a little different process called a stable auroral red arc that is not visible to the eye. That is something only the cameras really capture. But when the aurora gets bright during a very active display, those curtains take on a pink fringe as well, which really ripples and dances, as I showed you earlier on. And that's from molecular nitrogen. And it only gets excited and glows when the electrons have enough energy to get right down to the, well, not the bottom of the atmosphere. It's still 50 or 80 kilometers up, but into a denser part of the atmosphere, where the molecules of nitrogen can now light up, and there's more of them. But it takes a pretty energetic aurora to excite that part of the atmosphere, but it's still up very, very high. But you can see those with the eye when it gets bright. But it's the cameras that do pick up the colors, all the colors, very, very well. So any kind of camera will do the job when you go on an aurora chase. So how to capture the aurora? I do this almost every night. There is one out from my backyard, although I should say that sometimes they're just such a low-level fuzzy display, it's not even worth it. Kind of go back to bed, something that someone might get excited about from farther south. But when it gets really good, it's pretty amazing to capture. And these days your phones can do it, you know. And aurora tourists, they all have phones with them. Usually they're easier to use than point and shoot cameras and the like. These come specialized apps that I recommend for people with iPhones. The Android apps, usually the Android phones, the native image or camera app on Android phones is usually the best choice. But on the iPhone, there's these Northern Lights photo takers and nightcap and things like that that can take several exposures and stack them together in the phone. Just hold the camera very, very steady, and you can get a pretty decent, you know, shot of the Northern Lights, enough to say you got a picture of it with just the camera you already got in your pocket and a $2 app or something. And so it works. They work pretty well. But if you really want to get a good shot of the Northern Lights, you use a camera that you might already have for astrophotography, a DSLR or a mirrorless camera now, almost more popular, DSLMs, and any lens but a wide angle, because when the aurora gets going, you can't take it all in. You need a fisheye lens, like I show on the upper left, to really capture the whole sky. So you need as wide an angle as possible lens, and then very fast lens, as fast as you can get it, f1.4 to f2.8 as well, in order to capture the Northern Lights and freeze the motion, because when it gets bright, they're moving very rapidly. So you want to use short shutter speeds if you can, and a fast lens helps you do that. And the better the camera, the better the shots are going to be. So again, that's what a lot of serious photographers will have in their kit anyway, but perhaps not the fast wide angle. When the aurora is very faint, dim, slow aurora, the exposures are 10 to 30 seconds. Again, f2 to f2.8, lens fairly wide open. ISO 1600 to 3200. Pretty high ISO, certainly by the standards of a few years ago. It's pretty standard now, and good cameras now have no problem getting great shots even at a higher ISOs than that. And so when the aurora is faint and it's dim and it's not moving too quickly, a longer exposure isn't going to blur things too much. And when you want to do a time lapse, you can just take lots and lots of those pictures. And here, there's Steve appearing very briefly, just for about half an hour or so of the time lapse. And so we'll talk about Steve in a moment. But this is a fisheye shot that just happened to capture Steve in a brief appearance a few years ago. So you can do time lapse as well. If you can take one picture, you can take lots and lots with an intervalometer that just fires the camera every second. As soon as a picture is finished, you fire the shutter again and you just let it go for as many as you can. Now, when the aurora gets very bright, however, especially if, say, the moon happens to be up, as it was for this shot, the exposures should be and can be much shorter. Only 1 to 4 seconds, perhaps. Still, a fast lens helps in order to keep the shutter speed short. And the ISO speeds can be quite a bit lower, 400 to 1600 tops perhaps, to keep the noise down and as well. And so a very bright aurora is easy to capture with quite short shutter speeds. And you want to do that to freeze that rapid motion. And I like this picture because it was featured on a stamp issued by Canada Post a couple of years ago as well, one taken up in Churchill. So I'm kind of proud of that picture of the Northern Lights. And that was one frame out of a couple thousand I took that night of the aurora in a rapid time lapse, just taking shots every couple of seconds, like a 2-second exposure, and as soon as one's finished, another one starts. And so rapid fire cadence time lapse, and then strung together and slightly blurred together. It's sped up, it's time lapse, but it gives you a better idea of the motion, the flow of the Northern Lights. So it's not too unlike what you would have seen with the eye had you been there as well. So rapid fire time lapses are kind of neat way of capturing the Northern Lights as well. But the camera's got to work in the cold for an hour or two. What cameras can do now, particularly the mirrorless cameras, DSLRs not so much, but mirrorless cameras. This is the Sony a7 III. I have the Canon R6 now, which is about as good as the Sony cameras are for doing Northern Lights real-time movies, 4K movies as well, but ISO 12,000 to 51,000 or so. But in a movie, it's kind of tolerable. The noise and everything is fine, and now you capture the actual motion, what your eye actually did see and could see as well. So you can now do these real-time 4K movies. What was unheard of 5 years ago, certainly 10, 12 years ago, you needed tens of thousands of dollars special cameras to do this. Now any camera, well, not any camera, a good DSLM camera, mirrorless camera that you can buy off the shelf will do it. But a fast lens is still key. Very fast lens is still key. Well, just to finish off here, talk about one of the unusual forms of aurora called Steve that you may have heard about and kind of discovered here in my area. He's often seen in my area. In fact, here he is over my house earlier on this year, I think it was, in a brief display. It's kind of an anomalous arc that's been seen for decades, centuries, but only kind of recently identified as a unique phenomena worthy of separate study. Because of photographs taken by amateur astronomers, photographers like myself, saying, look, I've captured something unusual here. What is this? Pointing it out to the professional researchers, they say, we don't know. What is it? And it's now called strong thermal emission velocity enhancement. That's what Steve means, but it's a backronym. Because when it was first kind of identified as a unique phenomena a few years ago by amateur photographers in my area here with the Alberta Aurora Chasers Facebook group, people were saying, oh, it's a proton arc. Look, I captured a picture of a proton arc. And the professionals said, no, that's not. It's not a proton arc. That's not what a proton arc is. It's a misnomer. It's don't use that term. So the suggestion was, well, from the leader, in fact, of the Alberta Aurora Chasers group, Chris Ratzlaff, let's call it Steve, because it's a name the characters in the movie Over the Hedge, a Disney movie, gave to some mysterious thing that lived on the opposite side of the hedge. They didn't know what it was. It was mysterious. It was a little scary. Let's call it Steve to make it more friendly. And that's Chris suggested, well, why don't we just call it Steve? And it got backronymed to strong thermal velocity, emission velocity enhancer, because Steve is not an aurora per se. It's not caused by aurora particles raining down, causing these curtains, vertical curtains. It's caused by electrons flowing east to west. And very hot electrons, several thousand degrees, quite high up. Higher than the sort of brightest part of the aurora, 250 to 300 kilometers altitude. And those numbers have come from amateur photographs, including one like this, one I submitted here to one of the papers, where people triangulated. We're all out around Alberta taking pictures of the same Steve, and so the professionals can use parallax to triangulate where it was in the sky in terms of high altitude, what the altitude was. So amateur photographers have been very instrumental at not only drawing this attention of professional astronomers to this phenomena, but contributing data, contributing photographs used to study it as well. So exactly what's causing this hot gas flowing from east to west, we can see it with our eye moving from east to west, is still a matter of ongoing research from NASA satellites and from ground-based research as well. It takes on different forms. Here is a very thin, emaciated Steve across the sky as well, but he's always south of the main auroral oval. And it's always after a big storm. We get a bright display, it subsides, it heads back to the north, and then you watch and you wait, because that's when Steve's going to appear. And that's often the case. It was the other night as well. It didn't appear till quite a bit later, but it's often always after a major outbreak. There's something that's setting up these hot flows of hot gas and causing them to go from east to west after a major outbreak of northern lights. So a fascinating phenomena. There's another phenomena associated with Steve called these picket fence fingers, where there's little green fingers that flow along as well and that ripple along the sky, and those do seem to be more normal electrons raining down. It's a complex phenomena. No one's really figured it all out yet. Here's a classic Steve here. So it's quite amazing that for something that cultures have seen for thousands of years and told stories and myths and legends about, and for all the modern research and capabilities we have today, what's going on above our heads is still somewhat of a mystery. And it's an amazing story that amateur astronomers have contributed and are contributing some major areas to this area of research and contributing our pictures. The professional researchers are very much interested in getting our photographs here. Here's one from a couple of nights ago where is this a Steve? It's hard to say. What is this? Is it a SAR arc, this stable auroral red arc? Maybe that's what I thought it was, but it may not be, because it looks like it's got kind of radial structures going up and down vertically. What is this? So there's all these odd auroral phenomena, which the digital cameras are now capable of capturing, and that's been the revolution. And so it's opened the eyes to professional researchers to study and learn more about what's going on just 300 kilometers above our heads. It's an amazing story. And so there's lots of great science associated, but the bucket list experience is just standing out there, whether it's the cold or whatever it is, and heading up to see the northern lights and watching this display. Because when it gets active, it's just hard to imagine what nature is capable of doing and how the sky can burst open like that with these incredible displays of motion and color. And you really want to check that off your bucket list. Like seeing a total eclipse of the sun, which hopefully you saw in 2017 and will again in 2024. You want to see the northern lights. And just like total eclipses, you got to chase. You can't wait for it to come to you. I have that fortune down here, I can do that. But anywhere else in the US, you pretty well have to head north, up to Alaska or up to northern Canada or Norway, Scandinavia, or Iceland as well. So I hope you will do that and chase the northern lights. So it's my pleasure to speak to you this evening. We hope you enjoyed the presentation. My name's Alan Dyer. That's where you can reach me at amazingsky.com is my website. And I am the co-author with Terrence Dickinson, The Backyard Astronomer's Guide. Brand new edition just out this year. In fact, this autumn came out in September and October this year, hitting all the bookshelves and bookstores and retail outlets as our new, greatly, hugely revised 4th edition of the Backyard Astronomer's Guide. And so I thank you very much for your attention this evening, and perhaps we'll be able to go live now for some Q&A. Thank you very much. Thank you very much. That went quite well. That was fine.
That was a great talk. A lot of information, a lot of beautiful imagery. Thank you very much. Thank you very much. Thoroughly enjoyed it. So before we go into Q&A, actually, let's do commentary on your book. We had Docs have something to say about it. Doc, can you tell us?
I bought the original book back in the 90s and thought it was everything you ever needed to know about astronomy, everything in one book. And I've recommended it to OCA members and students and so forth over the years. And the new book came out and I said, well, I don't know. The other one was really good. So I got a chance to look at it and it blew my socks off because everything's been updated to within the last couple of months. And there's a lot that's happened in the last even 10 years. And I liked the color pictures. It was like the other book was good, but you could really get in and see things. I think, Alan, your point of view of how to show us things so that we could understand what they were by the picture rather than just showing a picture of a celestron equatorial mount. You explain the equatorial mount and have a picture that shows us what you're talking about. So it's really, I think, just a really good book, and I forked out the money right off the bat. I didn't even wait. And everybody that's seen it has said pretty much the same thing. Nice job. A really Textus Receptus, Alan. It's a Textus Receptus.
Yeah, this was the previous edition, which you might have had. With,
no, I had the white one.
Danny's beautiful picture of the horse head on it. But that came out in 2010. And that's what we replaced just, we started to work 2 years ago, but it got published. In September is kind of when it started to come out, hit the bookstores. So that's the new 4th edition. It's got, 32 more pages or something as well. And we added more star charts, star hopping guides that Ken Hewitt-White contributed to. I actually had lunch with Ken a couple of days ago in the West Coast here. The only face-to-face meeting there's been between staff and writers of the Backyard Astronomers Guide. It's all been remotely and Dropbox and all that kind of stuff. So we're very pleased with that. It's published by a Canadian publisher, Firefly, but it's available worldwide through all your favorite outlets. Bookstores and online outlets and the like as well, and I think is doing reasonably well. Certainly, checking the Canadian Amazon, it's a bestseller. so we're very pleased with that.
Great. Thank you very much. Now, heading into questions, let me remind everybody that you can send us your questions for Alan through the Q&A. So the first question, you solved a lot of you addressed a lot of misconceptions that people might have about auroras, their origin, their place. You also mentioned about magnetic poles of the Earth and geomagnetic poles of the Earth. Can you elaborate a little bit more about their differences?
Oh boy, I wish I could. I've asked the experts on that, and the explanations sort of woo as to the difference between where your compass points. The point where your compass would point straight down is the magnetic pole, and that's what's moving. But the geomagnetic pole is not the same, and that's the sort of extension of that virtual bar magnet that's inside the middle of the Earth, and it's not right at the core. It's the magnetic fields are generated outside the core in sort of the outer core and offset. They're not necessarily centered along the axis, plus they're angled. And those magnetic field lines then stretch out into space, but they're generated in the Earth. And the locus or the focus of that is the geomagnetic pole. And it's not really moving around much. And I don't profess to understand the difference between the two poles. There's 2 magnetic poles at each hemisphere. Same thing in the southern hemisphere. And I didn't really get into the southern lights, but there's whatever's happening in the north is happening in the south, except not as many people are seeing it in the south because there's not as many people in the south underneath where the main southern Aurora Australis oval is. And it has to get pretty, the KP has to get up pretty high, 5 or 6 or something, for it to go north enough for people in Tasmania the New Zealand, southern part of New Zealand, and the southern part of Australia, South Australia. Well, Tasmania is Australia, but the mainland Australia, South Australia, Victoria, those, you know, they're on the lookout then. And the pictures that I see, I mean, they're lovely pictures, but I go to bed if I see something like that in the north, you know, maybe, and they're raving about it because it's not getting as far north as it needs to. It has to be pretty active. And so people in the southern hemisphere don't see it as often as we do here. So Aurora Australis tourism is a lot tougher. There's Aurora flights that leave out of Australia and head down to the oval and then see it from the air. More of a guarantee to see it. But to go to Tasmania or Australia for 2 or 3 weeks, as I've done, boy, it's got to really hit a high KP. Just like going up to even the northern United States, it's got to be a pretty high KP for it to come down for you to see it.
When my wife and I have gone to Fairbanks a number of times to see the aurora, we do it in March, the second weekend in March, when you have longer nights and less storms. But we also take a red-eye flight out of Seattle out and back, because if we do get weathered out, we get to see the aurora from the airplane.
Well, that's a good point. And if you're taking any kind of transatlantic flight, well, for most places in the U.S., certainly the Western U.S., over to Europe, you're going to go not over the pole, but you're going to go over the Arctic.
Yeah, you go over Iceland.
If you're going over, when you're going over, sit on the port side of the aircraft.
Yeah. On
the left side, because you may see the aurora off to the north or higher up, and then on your way back, sit on the starboard side of the aircraft, because there's a good chance as you're going over Greenland and that you're going to see the Northern Lights. Yeah.
And
like Antarctic tourists that go down there, you're not going to see the Southern Lights, because when do Antarctic tourists go? In Antarctic summer. It's obviously
that's right. Yeah.
So don't book on one of these great Antarctic expeditions and expect to see the Southern Lights, because
the winter in Antarctica is vicious. I mean, I hate to even think about it.
Yeah, and you can go online and see some of the marvelous aurora images and movies that some scientists at the South Pole Station take. Even they are not really underneath the main auroral oval, but they still get good displays at South Pole Station, and watch some of those amazing movies that they take, where of course they can be shooting them all night long, and then you have to think about the conditions they were in when they were taking those, and how cold it was, -50 or -60, and the camera was operating, and the camera operator was operating, and so.
Well, and the homeward flight is another 6 months away.
Yeah.
I was going to ask a question, if I might, Reza. Have you ever heard the aurora?
Everybody asks that. I've never heard it. I'm not likely to now, because I'm suffering from tinnitus and hearing loss, old age. I've never heard it, and everybody wants to ask that. And
I
tourists
heard it.
go up there and say, "Can we hear it?" And in Churchill, no, the wind will drown it out, and whatever.
I heard it once in Fairbanks.
It's one of these myths and tales and the like. And there's been research done on it to come up with a possible scientific explanation as to how very high level of electrical activity can be affecting some sort of inversion layer just above us, and causing local sound, because it's not sound from up there, but it's being generated locally because of shifting magnetic fields. So there is a possible explanation, but it takes very special conditions, and even a very bright display isn't going to do it. It has to be a very still night, and a temperature inversion is what I understand. But even then, the explanations are I think still lacking. It's still not convincing a lot of people, because if you can hear the sound, why can't you record the sound?
When I heard it in Fairbanks, I was standing out on a very calm night, as you say. The aurora was pretty good. The sound was like crackling, like melting snow, but not quite the same. It was
That's
not
what everybody, as a crackling, which seems to actually relate to the motion, like it seems to correlate.
But
And
from behind me, not in front of me.
yeah. And because there's also a similar thing with a very bright meteor going around where people report hearing a sound coincident with them seeing the meteor. Well, that can't be because it's, you know, it's 80 kilometers up or whatever. And so if, you know, my point is you've got a recorder, take it out and record it. And nobody's done it yet.
Yeah.
The only recordings I've heard online that are reputed to be of the sound of the Northern Lights were taken under power lines, and it's power lines going wang, wang, you know. And so that's not the sound people are reporting.
No.
And so it could be that it's not a sound that people are hearing and can record, but try it. A negative recording is still evidence.
Yeah.
Well, maybe it's a sound that is, you know, being generated in here. It's one of these strange areas of science that is very fascinating, but doesn't have a good explanation. And only a handful of people are working on this because it's so tough to research.
Isn't it weird we know so little about something so close?
Absolutely. And that's the case with the Steve, as I said. That's a phenomenon that's been observed for decades, well, centuries. People, you know, records are being found of people seeing these anomalous arcs, but only since 2016 has it been identified as a unique phenomena. And then satellite data looking down on it and satellites passing through, Steve, getting the data to say what it is. It's this hot flow of gas. And there were other kinds of horizontal flows being in the literature before that called, well, the SAR arcs and SET arcs and things like that. But they were always thought to be very subvisual, and most of them are. But here is something we're seeing with the eye. And then the cameras pick up this pink color, which is probably nitrogen. And then the green is oxygen, and then the white in between as well. So it's continuous spectrum as well from this very hot gas. And so I was a participant, you know, through the Zoom thing last month at a international conference, small conference, a couple of dozen people. But we amateur astronomers, citizen scientists like myself, Chris Ratzlaff, Neil Zeller, John Anderson, local photographers here, a lady over in Finland who has done a lot of work on another phenomenon called dunes, which is another kind of horizontal formation of aurora. That was only identified a couple of years ago. And she was a participant along with a research scientist from NASA Goddard and research institutes. And so here we are, you know, amateur astronomers rubbing shoulders with the professionals because we are contributing the science. That they love these pictures and love to get these as long as we know exactly where we were and when we were when we took them.
Great. Now, people are asking if you know, auroras are basically bombardments by high energy particles. Does that indicate the radiation hazard? Maybe when we are directly beneath them, or
not for us, because that stuff's not getting down to the lower atmosphere. But when there's a very strong magnetic storm, there are warnings that go out to the transatlantic flights to perhaps take a more southerly route. Now, of course, they're still in the stratosphere, but they're not up in the ionosphere where this stuff's happening. But nevertheless, the radiation levels do go up. I can't tell you about how much. And so that's one of the warnings that go out when there's a big magnetic storm underway, is that polar flights may be diverted a little. And certainly people that are doing those all the time, the pilots and crews, they are subject to more radiation. Absolutely. And then, of course, astronauts on the space station as well, and the increasing number of private astronauts going up there for joyrides. But they're below, you know, they're below the Earth's magnetic shielding for the most part. But nevertheless, you're going to get a higher dose of radiation. The concern is the moon missions to come and the Mars missions. They got to solve that, because you're exposed. You're right out in the open, going to the moon and Mars.
Thank you. And you mentioned about when it's best to observe the auroras. Can you tell us about usually how long does these shows last?
A really good outburst, a substorm outburst, might only last 10 or 15 minutes. I mean, there'd be aurora going, and you think, oh, that's pretty nice. And all of a sudden, it just brightens up, and it maybe brightens up from the east, and it comes roaring in, and it just suddenly shoots around, and then will subside again, and perhaps subside into what's called sort of pulsating auroras, where it's just patchy. And that's what happened a few nights ago, November 3rd, 4th, and I slept through part of it, where it was just suddenly turned into this pulsating patchy aurora, but the really bright display was maybe only for a few minutes earlier on. That can happen, or the display can go all night, but usually it does have episodes where it settles down and moves it a little bit, but then suddenly you start to see it suddenly picking up in activity and brightness as one of those magnetic reconnection events happened out in the tail, and then shot stuff down towards us, and it just lights things up, and it just energizes it, brightens, the motions really picks up, the colors pick up, the intensity of the colors, and then it'll subside and die down. And that was your show. And to say the tourists up at the Northern Study Center, we will come inside, it's subsided, it's gotten kind of quiet. We come inside, we have coffee, we'll warm up or whatever, because it's -30 or whatever. But we're always going to keep on a watch on the sky, because it could sneak up on us. And suddenly we all rush out again and have a look and catch the big show. And then we're happy. So yeah, it can be not till 1 o'clock in the morning or something when it really picks up. Typically, it's at its best at local midnight, because that's when your position on the Earth, you're looking right down the tail, and so that stuff's coming right at you. And so typically around local midnight is when I say that's the aurora hour. That's the witching hour for aurora. Not always. It can be going great at 7 p.m. It can interrupt our dinner. It can interrupt my evening talk, whatever, but typically not till later, because that's when you're looking straight down the magnetic tail.
Great, thank you. And humans are notoriously bad at predicting long-term weather. How good are we at predicting the future of auroras, like 48 hours, or when do these alerts come?
It's gotten much, much better because of the early warning satellites we have in place. The Discover satellite, the ACE satellite, SOHO and the like, that are not only looking at the sun and seeing the stuff coming, but it's flowing past them before it hits us. And so there's warnings that go out 2 or 3 days before that the KP could head up, that a coronal mass ejection is coming our way. So watch out. And those warnings aren't just for tourists. Those are for satellite operators and power system operators and airlines, things like that. I mean, it's for a very important reason. So they can take protective measures, because auroras have caused blackouts. And so they can be accurate or not. On the night before Halloween, October 30th, there was warnings out that we're going to get a high peak. Going to KP6, it was going to be a fantastic show. What was it? Was that a Friday night, Saturday night, or something like that? And so ideal, perfect, great. The news reports go out. Oh, Aurora's expected down in the United States. And I went out here and there was nothing. Whatever was coming towards us missed us. And so we don't have enough satellites and enough buoys out there, placed there to see this wave coming past us accurately enough. It just missed us, did nothing. or the KP can go up high and the BZ doesn't go south, and it just doesn't connect and doesn't cause anything, at least for southern latitudes. But then 2 nights or 3 nights later, November 3rd, 4th, I think the warnings came out even just that day. I forget now, it wasn't well in advance. That was a bit of a surprise. And it was the best display people had seen for years here locally. And it went well south as well. And people saw vivid colors and it pulsing all over the sky. It was incredible. November 3rd, 4th night. And so there can be predictions even a month in advance, because they know something, a coronal hole or an active region of the sun is going to come around again one solar rotation later and may produce more of what it did the last rotation. But that's just, just a guesstimate. And so you don't really know until you're out there and looking up.
And this is for the KP, right? Do we have predictions for the other measurements? The scales?
No, I don't think there's predictions for the BZ. There's actual data from the satellites that are upstream measuring it coming past us. And so we can see they're measuring going south. So you kind of see, it's going to go south in an hour or so. No, I don't think there's predictions for that I'm aware of. So it is mostly KP index, which is a global magnetic field disturbance index. And that's kind of the main number. There's other numbers like the field strength and solar wind speed and solar wind density, things like that as well, which are measured, but I don't know how much farther in advance those are predicted.
Thank you. And now to the photography. You mentioned one of the most important things is to keep your equipment operating. Any tips, advices?
When you're going up to very cold regions like Alaska, like Doug was saying, Alaska in March, I mean, it's going to be pretty cold depending where you are in Alaska. On the coast, it's warmer, but if it's warmer, it's tending to be cloudier. You go inland, it's more Arctic and it's colder. And so how do you keep the cameras operating? I didn't show a picture of it here, but I've got little camera parkas, little neoprene, whatever they are, parkas that I can put cameras in, and you can put some heater, hand warmer things in there as well, and to help keep the camera warm. It's surprising, however, how well they work in the cold. It's you that gives up first. The cameras work surprisingly well. I've had things like memory cards fail when the camera gets cold somehow, and then that card's no good, and you're going to use another card. Take spare cards. Because if you're just doing still pictures, you're out there for maybe half an hour or something like that. You may not be out in the cold for all night long. You don't want to be in a place where you have to sit out in the cold all night long. You want to have something warm to retreat to somehow. It's time lapses where you want to get the camera going and shoot for an hour or 2 hours to do time lapses. That's the challenge. That's where the cameras can start to fail. But even so, I found with just one battery in a modern camera, I found that they can go an hour and a half. I'm just often surprised how long they're going for before the camera just dies because the battery has died. As soon as the battery warms up, it's fine again, And so taking more batteries, but also a dual battery pack. If your camera has that, that's a good idea. But just keeping it warm, even just inside a the camera parka thing, you can go online and see these for sale that allow you still to get your hands in and access the camera and operate it. I use those, and they can double the length of time that the camera can operate for. It's quite surprising. But as I say, it's you've got to operate this stupid little camera with your fingers, and you're cold. Your hands are getting cold. And so you want to just get really good at operating your camera and presetting the camera and having to do as little as possible outside there when it's really -30 or something like that. Just get it going and focus. That's the thing, is that you get everything set and then you blew the focus because the lens shifted something. So all kinds of things can go wrong. And you're not aware of it till it's too late, perhaps.
Okay,
But
thank you.
It's these things. I was talking about phones being really great. These things can do some really good pictures. We take them out in the cold. These things die in 5 minutes, right? I mean, I don't know how yours is like, but the iPhone, that's it. As soon as it gets cold, these phones are dead. They bring them in and warm them up, they're fine. But it's the DSLRs and everything that have a much beefier battery. They actually last pretty good.
Could there be problems with the other parts? Maybe the tripod freezing and stuff? Has that been ever a problem for you?
I've not had that a problem because I'm using pretty good equipment. If you're using little plastic flimsy tripods, forget it. That could break. That could break. No, you want to have pretty good equipment. No, other parts are fine for the most part, but you have to get familiar with using your gear. It's like an eclipse. Don't buy that camera, that lens, that tripod just for this trip, and then it's the first night you're using it is the Aurora, and you don't know how to operate it and where the knobs are. And people call me over and says, "Can you help me operate my tripod?" No, I can't. I don't know where the knob is for this. And if I turn this, your camera could fall off into the snow. You have to get familiar with your equipment and have used it. Not necessarily at -30, but you've used it in the dark. You know how to operate it and just practice with it. But other equipment doesn't. I've never found that those really fail too much.
Great, thank you. And the next questioner wants to know if we have observed, or is it possible to have auroras in other planets?
Oh yeah, the MAVEN in orbit around Mars has observed auroras on Mars. They're very patchy and they're not visible to the eye, or they wouldn't be visible to the eye if you were there. They're very patchy. Why is this green? Oxygen. Where is there oxygen elsewhere in the solar system? There isn't. This is green because we have life on the Earth, because it put the oxygen in our atmosphere. On Mars, there's carbon dioxide, and I don't know if it's what that's going in ultraviolet or something. It's very patchy because there's no organized magnetic field on Mars. It was lost billions of years ago, and the solar wind then blew away the atmosphere of Mars. And so, but there's still little patchy remnants of it. But Jupiter and Saturn, Jupiter in particular, have immense auroras. But with Jupiter, I'm understanding that it's more due to the Jovian magnetic field itself, and not so much with the interaction with the solar wind. And there's actually Io dumps material into the magnetic field of Jupiter's magnetosphere, and some of the auroras are that lighting up, but also just the auroras that Hubble and Galileo and Cassini at Saturn observed. Again, what's glowing? Hydrogen or whatever. It's not oxygen, so it's glowing in ultraviolet or infrared. It's glowing in wavelengths that if you were there, your eyes wouldn't see the aurora as well. Uranus and Neptune, I'm not sure about. I think maybe they might have them. I'm not sure. And then there was Ganymede has a magnetic field and a little bit of an atmosphere. And I think there's been some detection of auroral activity of some kind, not necessarily an oval, organized oval. I think.
Thank you. And you briefly mentioned a little bit about Aurora Australis. So are we expecting to see this same show, or maybe it's going to be different colors, different, or they're supposed to have simultaneously, right? From North Pole and South Pole.
They're pretty well mirror images of each other. There's some differences. There can be some differences from the north to the south, depending on the season and the tilt of the Earth, which hemisphere is tilted toward or away from the solar wind or the magnetic tail. Auroras are typically more active in around the equinoxes, March and September, when the Earth is kind of more straight up and down, and in relation to the magnetic tail, and both hemispheres are sort of equally receiving material, but they're more or less mirror images of each other to a large extent. And in fact, sometimes when researchers want to do research on something like Steve, if they don't have data from a satellite in the northern hemisphere, but it was over what they call a conjugate location in the southern hemisphere, they can be pretty sure and it passes through the zone and they measure a Steve or something like that, that if they measured it in the southern hemisphere, the same thing was going on in the northern hemisphere, because they're pretty well mirror images of each other. And in fact, the pulsating auroras that we sometimes see towards the end of a display after a big substorm subsides, and then the whole sky lights out pulsing, is actually electrons not coming down from the tail, but electrons trapped in a magnetic field that are bouncing back and forth from mirror point to mirror point, just going back and forth. And as they do that, they boom, light up a bit of atmosphere, and then they bounce and I don't know how long it takes to get from one hemisphere to the other, but it's not very long. And so that's what causes a lot of pulsating, these electrons and protons bouncing back and forth within the inner part of the Van Allen radiation belt, not from way down in the tail, where the aurora curtains, material that forms the traditional curtains, are created.
Great, thank you. You mentioned that auroras do not cause any radiation hazard for people who have their feet on the ground, but you mentioned one of the causes, one of the troubles it could cause is for the power grids. Have you experienced any in your area? Is that something frequently happening?
No, and I don't know why. I don't know if there's been any record of that here. The power grids here locally maybe don't extend far enough to set up a large enough potential voltage difference between north and south. When there's been, well, the legendary blackout caused by an aurora was March 1989. This is well before we had SOHO, we had any of these early warning satellites, and the Quebec power grid went off, and then it tripped down the eastern seaboard of the US, March something 1989, when it was a solar maximum, was a really massive display. And so you need to have this long metal grids, metal structures extending over hundreds of kilometers from the hydroelectric plants in northern Quebec down into southern Canada and the US, where Quebec exports a lot of the power into the US. And I don't know that that's happened since that I'm aware of, because they're aware of it now and they know that, and they can take precautions, whatever they do. I don't to shunt power around or whatever, shut things off and take precautions, because we have the Space Weather Prediction Center out of NOAA using the satellite data. But you probably heard the stories that, if we have what's called a Carrington level event, Richard Carrington, I'm just reading the book now called The Sun Kings, which talks about Richard Carrington. In 1859, I think it was, saw this massive flare, solar flare on the sun. He was plotting the sun every day, sunspots, and saw this. And then 2 or 3 days later, or a day later, auroras were seen down into the tropics. I mean, it's just astonishing. The sky lit up red in the Caribbean and in the South Pacific Islands. and the telegraph lines lit up. People were electrocuted. Well, that was the Victorian internet, right? The telegraph lines. What would happen today if that sort of event happened today? We depend upon satellites, the GPS satellites. Everything in society requires those GPS satellites now. Your cashiers can't ring in, whatever, without GPS operating, right? And so what would happen today? And that's the concern, is that we have enough warnings and precautions that we can take to prevent a major disaster, where if transformers blew out. I showed maps in my other talks to the tourist groups, where how many transformers would be blown out across the United States, and there's not enough. There aren't spares. It would be years before that infrastructure would be replaced. So it's a serious concern. We're so dependent on this high tech now.
So is that a matter of when, or is that a matter of if such a thing happens?
It's probably a matter of when, I would think. I show a video in my other talk saying, what was in 2012? There was almost a Carrington level burst from the sun that blew a coronal mass ejection, and it missed us. So we dodged a bullet. And this next solar max is predicted to be low by some, but by others very high. But even so, even low solar maxes can produce some major events from time to time. And so I'm not up on what precautions are being taken and by the authorities and power grid operators and all that, satellite operators around the world. If a massive event, and they know now what that could do, what they would do. I mean, you may require putting people into the black and without communication for some time, just to prevent to shut things down, so they can then reboot society, as it were, once the storm clears. I'm not sure. So that's why there's a lot of research going on into this, and that's why we're launching all these satellites, and we don't still have enough up there to really give us a clear picture of what's coming and what it's doing in the magnetic field, in the magnetic tail, because these satellites are all orbiting around, and so they can't just kind of sit there. They have to orbit. They only pass through the interesting zones for a certain time.
Yeah, that's what we need to be prepared for. Thank you. And Alan, you do take tours to see auroras, right?
Yeah, up to Yellowknife, I just go on my own. I'm not leading tours there. Norway, I was the Aurora expert on tours on the Hurtigruten ships through an organization in the US called Rhodes Scholar. And it's a very big international, but it's based in the US, tour organization that takes tours, interested tours of around the world of all kinds. But they haven't seen them revise the schedule yet. We're putting people on these Hurtigruten ferry ships for Aurora viewing and sightseeing, and I was one of the experts on that. Those ended in February 2020, when they haven't started up again. In Churchill, I go up to Churchill, Manitoba, and I am hired by the Churchill Northern Studies Center. It's churchillscience.ca, and go there, and they're taking bookings now for next February and March for what's called learning vacations. And it's 5 days there and 5 nights. I'm doing the March sessions, and my colleague Ron Waldron from Saskatoon is doing the February sessions, or on my sessions start late February and then into March. His start late January into February. We avoid the full moon. And so the learning vacation sessions are something that anybody can sign up for. There's also Rhodes Scholar groups that go up there as well, and we talk to them, and you can sign on to those, but you have to go through Rhodes Scholar and join Rhodes Scholar organization and sign up through them for their package. But for the learning vacations, you sign up through Churchill Northern Studies Center. You have to get yourself there. You have to pay the airfare, whatever. and overnight in Winnipeg or whatever, and head on up to Churchill on the flight, calm air flight. That's once a day, I think, usually once a day to Churchill from Winnipeg. But once you're there, once you're at the airport to airport, you're taken care of by the Northern Study Center. It's an all-inclusive package. And you go dog sledding, and you go snowshoeing, and you go ski-doing, and you have talks from us experts every evening. And so you're busy during the day. All the meals provided. It's wonderful. And we eat, sleep, and stay right where you can see the Northern Lights. I showed a couple of pictures in the talk. And so you're out of town. It's dark. And there's a plexiglass dome, so you can actually just watch it in your pajamas if you want, you know, underneath the warm plexiglass dome. It doesn't fit everybody in the group, usually 24 maximum. But there some that if you're not interested in photography, you just want to watch the Northern Lights, you can just keep warm and watch it. But most of us bundle up and we head outside. And then if you had enough, go inside, go to bed. Or I stay up all night and I wake people up. You know, if the Aurora doesn't kick up to 1 or 2 a.m., I'm knocking on the doors and getting people up. So you don't get that service elsewhere. So yeah, churchillscience.ca.
Churchillscience.ca. So about the cost and stuff, we can check the website.
Yeah, it's all there. They have the sessions for next year. They didn't have anything, of course, last year, and the one in 2020. I was literally the instructor on the last group when lockdown started to happen. And but they had a successful bear season, which was again the first tourist season they've had for a while. They had a successful polar bear season, October, November, that just wrapped up at the Northern Study Center. The last group just left. And then February and March is typically, or late January, February into March is Aurora season. And because that's when the clearest skies are. So they're five-night program.
Okay, great. Thank you very much. This covers all the questions asked. And let me remind the audience here that the availability of the recording of the meetings depends on the wish of the speaker, and Alan has been graciously given us permission to make this available. So if you missed anything or you want to double check any information, you could rewatch this video online at OCA's YouTube channel, the link to which you could find on our website, ocastronomers.org. Again, thank you very much, Alan. That was a great talk, very much information. Loved it. Thank you very much.
Thank you for the invite.
Sure. And as the last remark, let me remind everybody that you could check our website, ocastronomers.org, on the calendar, all the events that are going on and the links to join them. Our next event would be the Open Spiral Bar, our social forum, which will be held tomorrow night at 10 p.m. Thank you for joining us and wish you great times ahead. Bye-bye.